HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 291, recorded live Thursday, November 3rd, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Damian Edwards about SignalR, a jQuery client-side library, and an ASP.NET backend.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking to Damian Edwards. Damian's got some interesting stuff he's been doing on the side with David Fowler. How's it going, Damian?
Very well, thanks, Scott. How are you?
I'm getting there. Doing a little bit of work with this new thing called SignalR. I'm going to be talking at a conference on Monday about it. But you did all the work. Can you tell me about SignalR?
So SignalR is a little library that David Fowler and myself have put together over the last few months that provides a persistent connection abstraction between the browser and the web server that you can code against as an application developer.
Okay, a persistent connection abstraction. So, a reminder might be obvious, but HTTP is a stateless protocol, so you make a call and then you close that call down, and then later on you might call again. It could be in a minute, it could be in a year, you don't know. There may be some underlying things like HTTP 1.1 keep alive and TCP connections and things that will deal with the efficiencies and inefficiencies of opening and closing a connection. But for the most part, you do a get, you do a post, and then it's over, right?
Right. So HTTP as a protocol is very much based around this idea of making a request and then getting a response, and then making more requests when the need arises. But web developers have found ingenious ways over the years to mimic persistent, in quote, real-time, unquote, connections between the browser and the server. Especially since sort of Ajax became popular, there's been a few techniques that people have used to get this type of logical, persistent connection set up between the browser and the server. And then more recently, we've had the appearance of the WebSockets standard, which a lot of the browsers are now starting to implement, which actually gives you a true full duplex TCP level connection between the browser and the server. But it's pretty raw because it's basically a raw connection. So SignalR is something that sits a layer above all of those different techniques, whether it's WebSockets or Ajax long polling or server-sent events. And it sits above this, and you code against the SignalR API, and then we'll take care of ensuring that the most appropriate persistent connection transport is set up and maintained between the browser and the server.
Okay, so explain each of the three things you just said. There's long polling, there's server-sent events, and then there's WebSockets. How do each of those work?
So let's start off with the sort of the lowest common denominator, which is the Ajax long polling. So web developers who've used Ajax are probably already familiar with the idea of polling. So the idea is I have some information that I show on my web page. It may initially get rendered as part of the original page HTML payload, and then I want that part of the page to update somewhat frequently without the user having to hit the refresh button and do a full page navigation. And so what you might do is use some JavaScript to do something like a set interval, so that every 3, maybe 5 seconds, you make an Ajax call to the server with some type of ID that says, this is the last time I got data. And then the server will reply with anything that happened since that time. And then when it comes back, the Ajax request comes back, you do some processing, and then it goes to sleep again for 5 seconds, or whatever your polling interval is. So the idea of long polling is that rather than us potentially needlessly hitting the server every 3, 5, 10 seconds, whatever our interval is, and a lot of the time in these sort of applications, there's actually nothing to show on every one of the polls. The hit ratio may be very low to the number of polls you're actually making on the server. And so the idea of long polling is that, well, let me just make an Ajax request to the server that contains some type of token that says, this is the last time I received data from the server. And then the server doesn't actually reply to that polling request until there is data to satisfy that request. And so that HTTP connection, that Ajax request, will just stay open until the server is ready to return it. And then once something happens in the server world to send that would require that data to go back over the response to that AJAX request, it'll complete the AJAX request, send it back down to the browser. The browser will quickly process it and then immediately send out another AJAX request asking for the next slot of data when it is available. And so we get this illusion of a persistent connection, and because when things happen on the server, you instantly get a response from the server because you already had a request open, a pending long poll request open to them, so that's basically long polling.
Does the client think that it's just a really slow connection? I mean, are we taking advantage of the fact that you can request something and it might take a second or it might take a minute and the connection won't fall down while it waits?
Yeah, I mean, there are issues around timeout. And so most of the times when you deal with long polling, you have to be able to gracefully handle the situation where the AJAX request just terminated for whatever reason. And then thankfully, most AJAX libraries like jQuery give us a graceful way of saying, well, when an error occurs, do this. And so in the case of long polling, all you're really doing is setting up a very tight long poll loop, which is basically a looped function that just continuously calls this AJAX method, opposed to this AJAX endpoint. And if an error occurs, it might perhaps create a delay of 3 or 4 seconds before it tries again, but then it'll just start again after that when that error condition occurs. Now, because the internet is not just browser to server, it's browser to about 73 other devices before you actually hit the target server. One of the issues, obviously, is that any one of those devices that you happen to be routed through on your way to the server could at any point in time decide to just kill your connection. And certainly corporate firewalls and cloud services, front-end proxies and things like that have a habit of identifying connections that have been open for a long time with no data being sent over them and just killing them immediately. And usually these timeouts are set at about 60 to 120 seconds or 1 minute to 2 minutes. So things like, SignalR, we sort of gracefully handle this. We have a server-side, there's a default timeout for long polling as it is. So we always, if nothing happens after 2 minutes on a long poll connection, we just send back a packet basically that says, oh, this timed out. And then our client-side library just knows to reconnect. And obviously, if before that time the connection is interrupted for whatever reason, the jQuery AJAX error logic is going to kick in, and we have a handler for that says, oh, an error occurred at the AJAX transport level. Let's wait 3 seconds, and then we'll try again. So it's a very, very simple recovery mechanism. And that's why AJAX long polling is sort of the lowest common denominator for doing this type of thing, because it's actually really, really easy to do.
Okay, so long polling makes a call from the client to the server and says, hey, I need some stuff. And then there's a pause, and the server will respond whenever it gets around to it, whenever it's got data. And that pause is okay because you've got other HTTP connections you can keep open. And we'll talk about the scalability ramifications of that a little bit later. But that works everywhere and basically works through any proxy, and it's pretty reliable. Right, because it's basically just standard AJAX, but the request just takes a bit longer than usual. Okay, then. So then what is server-sent events?
So server-sent events was a protocol, I think it was suggested by Opera back quite a while ago, a few years ago. They introduced it in some version of Opera. And it's basically it's like a formalization of long polling. And so it includes a client-side object. So in your browser, you'll be able to say new event source. It's a DOM sort of JavaScript object that you can create. So you say new event source and you give it an endpoint. And then what happens is the browser takes care of making a request to this endpoint and then keeping this connection open and then recovering if anything goes wrong. So like I said, it's really a formalization of the AJAX long polling. The one difference is that rather than whenever data is ready to be sent from the server to the client, with an AJAX request, AJAX long polling, the AJAX request ends. We send the data back, and that is the end of that particular AJAX request, and then we send another one. With server-sent events, once you've established the HTTP connection, the protocol actually says that the server streams data down to the client using a very simple sort of framing protocol in the standard HTTP response body. And so the response actually never ends. So rather than having an AJAX long poll where we send a request, at some point we get some data, that request comes back, and then we send another request. With server-sent events, we make a request with a special header in it saying this is an event source request. And the server will keep that request open and then just stream back little bits of information over the response stream as it becomes available. And then in the client, that event source object that we created, it has an API that sort of raises events that you can handle with standard JavaScript functions, so that when data comes back over the connection, you can run your code and do whatever it is that you want to do.
Okay, so this is effectively the same thing conceptually as long polling, except after that, you make the call, you hold the connection open, some data comes back. With long polling, the data comes back and the connection ends, and then you start it over again. With server-sent events, you keep that open in order to send even more data later.
Correct. And currently, all the browsers except Internet Explorer support server-sent events in some fashion, and it's fairly easy to implement on the server side because it doesn't require any special extra HTTP plumbing. It really is just a custom header that gets sent up, and then it's just buffering or not buffering, just immediately sending stuff down over the response and keeping the connection alive. Mm-hmm. So that's server-sent events, and that works quite well. We're still building our server-sent events transports at the moment, but it's certainly promising. And the advantage of that over long polling is around latency, because with long polling you have this period where once a long poll has come back, you've received data. There's this period where in the browser it's processing that data before it then makes another AJAX request. With server-sent events, obviously we don't have this issue because there's no connection reestablishment going on. You open a connection and it stays open most of the time. You just keep getting data down in somewhat real time. Now, server-sent events is a one-way technology only. It's only server to client. So to push stuff up to the server, you just make standard AJAX posts.
Okay. And have you built that into SignalR already, or is that something you said that
So we have a branch in our source at the moment that has an experimental server-sent events transport.
And is that tricky, or is that just a matter of, how do you test something like this?
With a lot of manual testing. Basically, at the moment, it's easy to test that you can get server-sent events working. It's very easy just to set up a handler and spit stuff out over it if it received a certain header. What's more tricky is figuring out whether server-sent events can actually take the sort of load that people expect to be able to push through something like SignalR. So, long polling, for all of its failings, it's a very low-level, lowest common denominator type of thing. You have this problem of latency and this problem of this, there are actually periods where you're actually not connected to the server because you're doing processing. For all of that, we've actually got our long polling transport really, really robust, to the point that, we've got demos where we have two browsers up, and they're sort of doing real-time moving of DOM elements from one browser being sent to the other, and they're sort of refreshing in real time. And that works really, really well, even over something like AJAX long polling. At the moment with server-sent events, we're having a few issues whereby when we start pushing a lot of sort of packets over the server-sent events connection, we see some things being dropped, and we're still sort of trying to figure out why that's happening. So that's why it's still an experimental transport at the moment.
Okay, but conceptually, you'll have all three of these things. You'll have long polling, server-sent events, and WebSockets all working in the same library. And the person that writes to that library, me, will not have to think about any of that stuff. They'll just have a great experience on any browser.
Correct. So that's the idea. That sort of brings us to the last one, which is WebSockets. And a lot of people are really excited about the promise of WebSockets because it gives us this true and formalized way of doing a persistent connection, a true sort of socket-level stream connection between the client and the server that's full duplex. The problem is that it's so new. So if you're a Windows user using Internet Explorer, you'll have to wait for Internet Explorer 10 to get WebSockets support in the client. On the server side, you need to be running Windows 8 server to be using WebSockets from within ASP.NET or WCF. Now, if you're using other browsers on the client, then Chrome and Firefox and Opera and those guys, they support WebSockets just fine on the client at the moment. But it's going to be quite some time until we can use WebSockets and hit the majority of your audience on a public-facing website because Internet Explorer still has a very high usage across the world. So it's going to be a long time before we can just use WebSockets everywhere. The other issue with WebSockets is it's a very low-level API. It's a socket. And so if you've ever done any socket programming, there are framing and buffering. And if you look at the APIs that are sort of in ASP.NET in the next version that's going to support this, you're working with array segments of bytes and this type of thing. And you have to make sure that you never try and send anything over a WebSocket connection that's actually closed. There's all these type of things that you have to worry about if you're writing against the raw WebSockets API. So the idea of SignalR is that, well, we just surface a really, really simple connection API with a very small amount of events, like, someone connected, someone disconnected, someone sent some data, and you want to, or perhaps you want to send some data to someone or broadcast some data, and that's kind of it. And then everything else is just built on top of that very, very simple, low-level connection API. And then underneath that, we have all these transports with the complex logic of maintaining this illusion of a persistent connection are taken care of.
This episode of Hansel Minutes is brought to you by Careers 2.0 and our friends at Stack Overflow. If you're not familiar with Careers 2.0, it's a career site dedicated to advancing your career as a developer, whether you find an awesome new company to work for, or create an online programmer profile, or even post a job within your own development team. A programmer profile at Careers 2.0 is an evolving archive of actual coding you've done, as well as your own blog posts, your favorite books. It's free, it's easy to get started. Just import your LinkedIn profile, add your favorite Stack Overflow answers, and even your open source contributions to GitHub, Bitbucket, and SourceForge. Even if you're not currently looking for a job, a profile on Careers 2.0 is a great representation of your programming knowledge. There is one catch. Profiles on Careers 2.0 are invite only. They did this to keep out the spam and create a high-quality environment. Fortunately for you, as a Hansel Minutes listener, we've hooked you up. We're going to invite you to join tens of thousands of other programmers who already have a profile. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. The fact that you can use JSON and you can use HTTP, and that they're hiding the complexities of the underlying TCP connection, that none of us have had to really worry or think about TCP in a long time, is something that I think people should appreciate and realize that that's pretty awesome, that you can throw a string across the wire and get a string back, and for the most part not think about the little tiny details that caused that string to get there. It sounds like with WebSockets we'll have to be thinking about that again.
Yeah, I mean, the other problem with WebSockets is because it's an extension to the HTTP protocol in a lot of ways. A lot of the hardware of the internet, I mentioned, these 73-odd devices that are between your box and the server you're hitting, they all have to understand WebSockets for this to really, really work. Because the way WebSockets works is you make an initial GET request, a standard HTTP GET request with a special header that says, I want to upgrade this request to a WebSockets connection. And then at that point, if the server understands that, it sort of switches the request from a normal request to a WebSockets request. And then the original HTTP part of it just goes away. And then from that point on, you basically have a true TCP connection from client to server. Now, that obviously may cause problems with the infrastructure of the internet when we think about, really it's been set up to work with this idea of a stateless request response model at the moment. So it may be some time before WebSockets becomes something that we can reliably use throughout the internet for that reason, as well as the reasons of browser support.
So let's explore that a little bit more and make sure that people really understood that. So HTTP itself, the protocol that we're all used to and we're all comfortable with, in this case is just used as a wrapper for a handshaking protocol. You go and you say, hey, do you support WebSockets? Yeah, I do. Which version? Well, I support this version. Well, that's cool with me. I also support that version. Now let's all step into a parallel universe, start another connection, and HTTP then stops being used, and it's not involved in the conversation anymore.
That's right. And so if you think about how large web servers are deployed today, we have this idea of server farms and some type of front-end infrastructure that knows how to load balance requests across a farm of servers. And if anyone who's ever built websites to any sort of scale will be familiar with this. And we have ideas of things like server affinity or stateless front ends. The problem with sockets is that it lulls you into this idea of, things are stable now. But we actually have this issue of that, if we want to build anything with scale, we have to figure out how we're going to scale this persistent connection across using the infrastructure that we have for doing this with request response sort of paradigms with HTTP. I have a server farm, I have a front end load balancer, a request comes in, okay, this is a WebSocket request. Which server is it going to go to? Okay, well, it goes to server number one. That server number one now has a hard connection through to this browser. Okay, well, I'm not really load balancing very much now because all that data is going between that client and that server. What happens when that connection goes down? Is my app written in such a way that if the WebSocket connection for that user suddenly appears at server 2, is it going to continue to work? These sort of things that we have to think about now when we're using these sort of protocols.
And that's why I bring up this analogy of the parallel universe, because this means that your large, well-organized server farm that's completely prepared for stateless traffic and load balancing across HTTP might be wholly and completely inappropriate and unprepared for real time. So you might end up with another whole network switch, another whole subdomain, another whole farm to manage that kind of traffic.
That's right. So it's an emerging standard. All the companies involved in this are working very diligently to get the standard to sort of the place where it can be readily implemented everywhere and people can start trusting it. But I still think it's going to be quite some time before this is something that can be reliably used for the majority of Internet users. And so until then, SignalR, I think, is and libraries like it, we're certainly not the only one, will really required to fill this gap until such time that we can just say, hey, WebSockets is great, we use it everywhere. But even when we get to that point, as I said, the WebSockets API is pretty low level, so we think our API is a much nicer place to be as an application developer.
So who is your quote unquote competition? I mean, there are obviously a lot of people in real time. Whenever we think about real time, we hear about products like Node.js, we hear about Socket.io, and there's different libraries that all claim to do real time.
Yep.
Is yours just the same?
Yeah, in a lot of ways. I mean, if you look at, we were inspired by a couple of things. I mean, at the end of it, to make it very clear about what this library is, this is a two-part library. It's a jQuery plugin for the client and a .NET library for the server, and it's designed to run in ASP.NET. So this is very specifically a persistent connection library for ASP.NET developers. Now, if you look at something like Socket.io, which is sort of probably the most well-known of these libraries for doing this type of thing, and it has the same concept of underlying transports, which it dynamically switches out and configures based on whatever the client is and what the server is. Socket.io was built to work with Node.js. It really is it's a server-side and a client-side library. Node is JavaScript, so it's JavaScript on both ends, which is kind of nice. And there are other people who have ported the Socket.io protocol, if you like, to other platforms like PHP and those type of things. Now we looked at Socket.io in the beginning, and we could have taken the option of trying to port Socket.io to ASP.NET. There's a couple of issues with that. One, we felt the API of Socket.io wouldn't have been as comfortable for ASP.NET developers. And again, we were trying to build this for all ASP.NET developers, not just the alpha geek, top 5% of developers. We wanted to make this library approachable for anyone who's ever written an ASP.NET application. And so we've sort of structured the APIs on the client and the server to sort of mimic .NET where it needs to, and then be nicely JavaScripty where it has to be as well on the client. And so as part of that, we invented our own protocol. When say invented, it just emerged as we built the thing, really.
Now, when you say protocol, though, you don't mean your own like HTTP protocol. You mean your own style of programming.
Well, no, I actually mean our own shape of the packets that we send over the wire. So remember, this is a client-side library and a server-side library that work together. And in order to do this in such a way, and we have to be able to cater for the fact that some of the transports that we use have flaws, and we have to be able to sort of spackfill over those flaws. There are cracks in how these things work, and we need to be able to polyfill those up so that everything looks kind of smooth from the layer that the developer uses. And so to do that, when you have a SignalR connection in the client and you say send some data to the server, we don't just send the raw data. We actually sort of wrap that data in some JSON, other information, and wrap it all in a JSON payload and then send it to the server. And then similarly on the server side, when you say I want to broadcast this data to all the currently connected clients, we don't just broadcast the raw data. We have to sort of broadcast not just your data, but a bunch of framing information that says, well, okay, this data relates to this connection. This is message ID number X. It was sent on transport Y, blah, blah, blah. So that once the client-side library receives it, it knows how to process and dispatch that to the appropriate JavaScript methods and events in the client-side library that we have. So that's what I'm talking about when I was talking about our protocol, like the actual bytes that go over the connection, whether it's WebSockets or long polling or server-side events, is a SignalR packet, in want of a better word.
Okay. Now, in the past, I've done, I mean, we've all seen like what we would have thought was real time, like I think the original real time experience that we've all had on the internet was probably 10 years ago when we hit Expedia.com for the first time. And we said, find flights. And then this animated GIF came up and it said loading and it looked like something was really happening. And then it would go, the screen would flash and then we'd get our results. And that was using a meta refresh tag and it was going, got results.
Yep.
That seems like a very obvious thing to do with SignalR. Like that would be a swap it in and out kind of an experience. Now, when that was being done, as you pointed out before, when you talked about polling, it was basically going, you hear me now? Do you hear me now? And it was beating on the server. It may have been a lightweight thing, but it was beating on the server. I could have probably opened a connection and tried to keep it open, but in the past, in ASP.NET, at least in kind of standard HTTP handler, I would be holding that request thread open. I don't think that ASP.NET would have scaled for more than 20 or 30 requests, and it would have just been holding them all open. How can I do that now? How did you fix that problem?
So there's a couple of things that have happened in the last sort of 5 years on ASP.NET that have allowed us to make this to do this now. So the first thing that's probably worth pointing out is how ASP.NET uses threads and why people perhaps have found doing this type of thing on ASP.NET hard in the past. So with ASP.NET, when your application starts up, it uses the .NET thread pool. This is the standard construct in .NET applications that sort of manages the allocation of threads. You know, threads being the things on the CPU that your code runs on. If you want to run more than one thing at a time, you need to have more than one thread running. When your ASP.NET app spins up, it gets so many threads added to a thread pool that's now running in your process or running in your app domain. Mm-hmm. And then what will happen is when a request comes in via IIS and it's handed off to ASP.NET, ASP.NET will take a thread from that thread pool and assign the request to that thread so it can run your code on that thread. And in standard ASP.NET programming, that thread will remain assigned to that request for the lifetime of that request. And this model was really designed to cater for the scenarios where requests are very short-lived, under 100 milliseconds. A request comes in, you do some processing, and then you return it very, very quickly. And the thread pool is very, very good at giving us threads and taking them back again at that type of rate. It certainly has no problem doing that. Now, prior to .NET 4, the way that the default numbers for the number of threads that you were allocated into your app pool for an ASP.NET application was actually very, very low, down in sort of the double digits. So I think it was something like 10 threads per CPU or something like this. So if you had a 4-core machine, when your ASP.NET application started up, you would have less than 100 threads perhaps in your thread pool by default, so that you really couldn't be dealing with any more than 100 concurrent connections.
Right. And which was designed to help throughput. I mean, if your goal was to serve as many requests as possible, you didn't want to spend too much time thrashing. That was an appropriate number of threads per CPU and was optimized for horsepower and throughput, but not for concurrency of persistent connections.
Exactly. And that's what we see is when we talk about these concurrency type libraries, these idea of real-time persistent connection libraries, the much more important measure is concurrency, the number of concurrent connections you can have open to the server rather than the throughput of the server. Because generally with the type of applications you're building with these type of abstractions, you're not having an awful lot of throughput. You're not sending dozens and dozens of packets to the clients per second. What you be able to do is have lots and lots of clients connected, and then when something happens, push something out very quickly to those clients in somewhat close to real time. And so we got to .NET 4, and a few things happened. First of all those limits were upped by default. So the number of threads allocated into the thread pool per CPU were drastically increased. There are other settings in ASP.NET that actually govern hard limits on how many concurrent connections can I have before I just stop serving requests. That got upped to something like 5,000 in .NET 4 by default. Prior to that, it was much, 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 much lower than that. Now, these were always tweakable, but as you said, they were architected like this because ASP.NET was really geared to serving certain types of traffic. So what we have now is this situation where we can take a lot more threads, but we still have this problem. I mean, okay, so maybe now I have 1,000 threads available to me, and I can handle a hard limit of 5,000 concurrent connections. But that's still not that many. Like, I'd like to be able to hold on to a lot more connections than that. Well, in order to do that, we have to come back to how ASP.NET deals with threads and requests. And so I talked about before that the default way this happens is that when a request comes in, ASP.NET assigns it to a thread, and that thread lives with that request for the life of the request. But we also have an asynchronous programming model inside ASP.NET that lets you basically keep a request open but dissolve all threads associated with the request until such time that there is work to do on the request. Mm-hmm. And so if you think about a persistent connection, most of the time what's going to happen is that the request is open but nothing's happening. You're waiting for some event to take place on the server so that at which point you'll send data down, sort of the stuff that we've been talking about. All that time while nothing's happening on the request, we don't want a thread to be taken up. And so we need to use the ASP.NET asynchronous programming model to do this. Now, this has been around for a while. I mean, async ASP.NET has been around since 1.1, I think. But it was very, very difficult because of the fact that the way you did async in .NET was something called APM, the asynchronous programming model. And people will be familiar with a number of APIs in in .NET where we have like a begin and end method pair, where the begin method returns an iasync result and takes in as a parameter an async callback delegate, which is basically the function that needs to be called when this async operation has finished. And then the calling code will end up calling the end method, passing in that iasync result that was returned. And that's a fairly complex coding paradigm to get around. And while it may be fairly easy to get your head around doing one of those, where it became really difficult is when you had multiple operations that were async that you wanted to chain together, or you wanted to sort of set up asynchronous loops where you did some work and then sort of went away and then at some point in the future woke up again and did some more work. And that type of coding was very, very difficult to do. So in .NET 4, the .NET team introduced this amazing library called the Task Parallel Library, or TPL. And this is a whole new set of APIs inside .NET that make doing this sort of asynchronous programming much, much easier. You don't have to deal with this APM model anymore. We have this task-based parallelism model now. And so rather than dealing with iasync results and method pairs, we now just deal with things called tasks. So a method can return a task, which is a promise. I mean, in other programming languages, we have this idea of promises. In jQuery, we have the idea of a deferred object, which is a promise. So this object that your method returned represents something, a task that will run in the future or it may be running right now, and then that task will complete when that function has completed. And then there are APIs in the TPL that let you chain one task to another. So you can say, okay, I now have this task, which represents a database call, and then when this task is finished, I want to go off and do this other code with the result of that first task. Mm-hmm. And you can continue chaining these tasks together, and then the .NET will just take care of scheduling all this work at the point when it actually needs to happen based on that sort of task hierarchy that you've built up.
And all of that being hidden from you by SignalR. So SignalR is hiding the protocols, it's hiding some complexities of scale. And people can use this today. I mean, we talked a lot about how WebSockets is not ready, but if the listener wants to go and use SignalR today, even on a production, what do you recommend to them?
Well, we certainly have people doing that already. I mean, from the library point of view, we're sort of still in the fairly early days. I think our version's like 0.3 something. We have a sample reference application up on App Harbor that we can point to, that we sort of hang out in. It's a chat application, so there's sort of an IRC clone. It's at chatapp.apphb.com. And so you can go up there and sort of get a feel for the type of application you can build with this. And then on GitHub, where our source is, we have a number of other sample applications as well. Now, we know of people who have built, who are now using SignalR in things like auction sites, so they can get real-time bid price updates on auction lot pages. We have other people who are looking at for using on things like sports sites, so that if you want to get sports scores up to date in real time, they're looking at using SignalR for that type of thing. And then we also have a scale-out story. So if you have a large-scale site where your website runs on more than one server, you have to be able to coordinate this the SignalR messages that go between the servers, so that if I have a client connected to server 1 who wants to send a message in real time to a client on server 2, then we have a scale-out story for that as well. We have a couple of APIs that you can hook into to sort of build in support for whatever scale-out technology that you're using. So you can certainly try using it now, where it's continually being worked on. We're still refining a few parts of it, but the more people use it, the better it's going to get. So
very cool. So are you going to, you have this also SignalR.net as a domain that you've been sitting on for a while. You're going to hook that up for me and make it so it redirects to where people can get the code?
Oh, that's probably a really good idea. So yeah, we do have SignalR.net with the idea being we'll put a website up there at some point, but for now we should probably just redirect it to the GitHub repository. So yeah, I'll go ahead and do that. Otherwise, you can just go to github.com/SignalR, which is the organization, and there's a bunch of repositories in there for the various parts of the library. Or you can just go to NuGet and just install package SignalR straight into your ASP.NET 4 application.
Very cool. Thanks a lot, Damian, for talking to us about SignalR today.
Not a problem. Thanks, Scott.
This has been another episode of Hansel Minutes. We'll see you again next week.